Hello and welcome to this video. In this video we're going to be talking about capturing values in Swift programming language. Now this video is a bridge in between like functions and closures because you really need to understand about scope and how functions can capture values. Now I'm not going to go super in depth into this, but I'm going to try and highlight to you what you need to understand. So first of all, we've got two functions here. We've got a make incrementer function. This is going to make the incrementer. It's not going to increment anything. And inside of it, there's a function called the incrementer. And this doesn't take any arguments, but it just returns an integer. Okay. But this make incrementer returns a function type. Okay. It returns a function type. And so the incrementer here, what we are doing is we are returning a function type, because incrementer has the same signature here. It takes no arguments, it returns an integer. And here it takes no arguments, it returns an integer. This has the same signature, and so it does qualify to be this one function type. So, but I just want to highlight, because I didn't talk about this in the nested functions, is all of these functions inside of a function, they are only available to this one scope inside of this one code block, but they're also available in other nested so in other parts of the code, all right, but only within inside of this code block. So if we write another function here, and tester or whatever, you could use incrementer inside of this one function too. And if you wrote another tester function here as well, you could use incrementer in this. So anything within inside of this scope here is available inside all of its child scopes as well. So this is one of the benefits of being able to use it, is you can declare your function inside of another function, and then you can return it as a function type, so it can be used outside of your function. Okay, so the usage of this is we are saying, let's just call this then the incrementer, and we are saying make incrementer, and we're going to increment by, in this example, by 2. All right, and if we just run this, you'll notice it doesn't output anything at all at the moment. And when we use the type annotation, we can see that it is a function that takes no parameters, no arguments, and returns an integer. So we want then let's just do print here, and we'll say then incrementer, and we'll then call it the first time, and then we'll run this. And you can see it then outputs 2. Let's just copy this again and do it a couple of times. Whoops. And do it a couple of times and run the code once again. You can see 2, 4, 6, 8. So what's happening inside of this one code block here? All right, we have first of all this running total integer. Use type annotation to see it, and type inference is running total of integer. It starts at 0. And this one variable is alive for all the time that if this nested function wasn't there, okay, then as soon as this code has been executed in make incrementer, this running total variable would be dead, it would be gone, all right? But because a nested function has captured this one variable inside this one incrementer, it has now a reference to it, all right? Which means that this running total variable cannot die right now. It cannot be garbage collected. Swift doesn't have a garbage collection, but let's just say it cannot be thrown away, all right? It cannot be disposed of, because something else has a reference to it, and that is the incrementer function has a reference to it. So when we return this one function type of function incrementer, this one variable, its lifetime here, has a reference to this running total. So every single time we use it, the value of this one variable is always being incremented, even though this make incrementer function has been called, and it's been called here, and it doesn't need to be, none of the scope of this one function is available anymore. However, because this running total variable has a reference to it, this running total variable is still alive for this one incrementer. And this is what I'm trying to say to you, is that it has a reference to it. So but we could make another variable here and just call test1 and of 1, right? But you couldn't access this one variable from outside this incrementer function. Okay, so once this increment, every single time this incrementer function is called here, this test1 variable has been created, and after the return function it's then disposed of every single time. But that's not the case with this run in total, because it has reference to it inside of here. Okay, so this is what's important to understand, is the scope of the function, and the incrementer here, its scope is inside of these curly braces, this code block. However, it can access the scope of its parent's function code block as well, right? And it can use these, and it can capture it, and it can keep increment it. As long as it's a variable and it's not a constant, it can do what it wants with it, and it'll always have access to it, and this variable will not be killed. I think I've repeated myself enough for this. So this is now showing you functions, first of all, that return function types. So function types. And you can see nested functions inside of here as well. We have gone over, once again, code blocks. We've gone over how you can capture specific values and how they stay alive. We've gone over the life expectancy of a code block, that after this one return incrementer variable, then that whole code block basically has died, apart from the run in total. And we've gone through then the type inference. Here you can see that this incrementer is of type function type, and we can use it over and over again, and this run in total just keeps getting incremented, and so on and so on. So this is really super important to understand for future videos about closures. All right, and in the next video I'm going to introduce you to closures. All right. With that said, I hope you've got something out this one video. I hope you've learned something in this one video. If you haven't got your head round nested functions right now, then I would suggest rewatch this and try and test it yourself. You can't access this incrementer from outside of this one make incrementer function, but you can only use it inside the incrementer function. The fact that we are using it outside is because it returned its functionality. Okay, so this is what you need to understand. It didn't return the function. You can't access the function of incrementer here. However, because we returned the functionality in a function type, you can use that functionality from outside. Okay, so this is a lot to take on if you are new to programming and you are new to this type of stuff. So don't be worried if it's a little bit difficult right now, because I've seen many developers bang their head against the wall not understanding this. I promise you, and no matter how many times you repeat it to them, they didn't understand it. So you won't be alone, but keep watching my videos and I'm going to make sure you understand it 100%, I promise you. Okay, with that said, yeah, I'll see you in the next video. If you do have any questions, then as all of the other videos, let's start a conversation in the comment section down below, and I will answer all of your questions. But don't worry, there's more videos coming about this one topic, so just be patient, wait for the next videos to come, and I will explain all of the other stuff that maybe I've not talked about in detail in this one video. Thanks very much. Ciao, ciao. Goodbye.